Okay, so we continue our lectures on object-oriented programming. We were introduced to the concepts in the last class, and we started an example. I'll briefly review the concepts, and the first one is abstraction. And we have the official definition here, but the simplest way to look at it is how an object views another object. In this case, a teller, ATM, or user or bank customer object can see that they can call open, deposit, or withdraw functions. But they cannot see the internals of the class or how the class is getting the customer information. And really, if you think about it, it does not matter. Like if we deposit, we never think like, how do they keep my information updated? Like we deposit and then we get a receipt, email, paper, whatever, and that's enough for us, right? As proof that we made a deposit. And that's, in a nutshell, abstraction, like how objects view other objects. Outside view of an object, right? That's why it's kind of like, well, how an object views another object. And then we also talked about encapsulation. And this one, in layman's terms, is putting variables and functions that give actions to an object in one class structure or object, right? To create an object. And why do we do this? Mainly, we want to protect the integrity of our data. The only one who can directly access balance is the bank account object. The only one who can modify balance directly is the bank account object. Other objects can deposit, and they are indirectly modifying the balance, and they can withdraw, and also they are indirectly modifying balance. So all the logic to make a bank account model are in the bank account class. And functions, what are they? Functions give actions to the bank account object. Unlike functions, when we are thinking sequentially, that's not the case in object-oriented programming. Instead, we have identified an object that we want to model from the real world, the banking world, a bank account. And then we give it some actions. And in the process of giving it actions, we need some variables to model that object, right? So that's encapsulation. And the formal definition is hiding implementation of an object by combining data or variables and code or functions into a single object. So, questions here? Well, maybe if you could see my screen, it would help, right? So, was somebody trying to talk? Because I couldn't hear anything. Okay, so briefly, right? So we have the bank account class, and then we have data, variables, and functions that give the bank account actions. And in a nutshell, this is encapsulation. And I was reading off this definition, right? Hiding implementation of an object by combining data and code into a single object. Data equals variables, code equals class functions, okay? Any questions? Okay, also, if we want to see how this looks in memory, assuming this code that you see right there is main, then this right here is memory allocated to our main function, and it's loaded onto the stack. Within this region of memory, we need memory for A. And if you recall, we only have one data or one variable so far, and it's balance. So assuming when our program's running, this is the region for balance, and we have a balance of 0. So that's how it will look in memory. And this region right here, maybe like that region there, would be for the A variable. Okay. Why am I bringing this up? When you create a function that's not part of a class, they are known as free functions. You create the function and you can use it. When you did your homework for the tax or anything that uses functions, you do like get tax rate. Once you have finished writing the code for the function, in main or in a test case, you can simply say get tax rate. Pass it any parameters it needs and you can use it. That's not the case with a class. Let me bring up Visual Studio here. Okay, so this is, I'll review the code in a little bit, just to give you a refresher of where we are, right? But when you create a class, in this class the name is bank account. It has one function, a class function, get balance. It returns balance. It has one data or one variable, balance. To use this class, you have to create a variable. Okay, we can't just say like bank account and use it. We have to say a bank account is my type, and this is the name of the variable. So when it's loaded onto memory, this variable is going to be in memory. Okay, and that's not the case for functions. And if you recall from using strings, that's what we do with strings, and I've told you that a string is a class. So notice here we have to create a variable, or in formal terms we have to create an instance of the string object in memory. And the same thing for bank account. We create, with this code right here, we create a variable or an instance of bank account object in memory. We can conclude that this is a blueprint, right? It's kind of like the model homes when you go see a model home, and or like a model car, and then they can a blueprint for a model car, and then they can manufacture a lot of model cars and deploy them all over for stores, right? So people can buy them. So this is the blueprint, and now this is us using our blueprint. Okay, questions here? And that's why I had shown you this screen. We have to create an instance in memory, and then what's loaded onto memory? The data, the variables. And right now we only have one, and that's why we only need one slot. Can we show or can we prove that? Yes. We can say cout, and we use size of account. So we are asking the compiler, hey, how many bytes does this guy take? Let me mute this piece right now. I go to src examples. And notice it says 4. Why 4? Because an integer takes 4 bytes of memory. Oh, is that so? Okay, so what if I create another member? And then I'm like, okay, let me go ahead and run it again. Should I see 4 or 8 or 12 or 20 or what? Well, it only makes sense that we should see 8, because now we have 4 bytes plus 4 bytes, 8 bytes. So if we would come over here, then we would have the other COSC ID right here. Okay, so it's important to understand that. And they are loaded onto memory. Questions here? So we'll go ahead and remove this and this. Okay, so no questions. Okay, so let's briefly go over this code. So we create an object or a class, and we say we are creating our own user-defined type. We name it bank account. This is required, open curly brace. Close curly brace is required, and so is a semicolon. And I said it in the last lecture, and I'll say it again, do not forget the semicolon. Like, you'll waste a lot of time trying to figure out what the issue is. Okay, so just remember, class name, open curly brace, close curly brace, semicolon. Okay, then we also talked about the access specifiers. We have a public access specifier, meaning wherever somebody creates a variable or an instance of our class. Let me remove string for now, we don't need it. If something is public, the users of our class, in this case main, can call that function. If something is private, like balance, users of our class cannot directly access. Notice right there saying that balance that belongs to the bank account class is inaccessible, meaning it's private and users of our class cannot. These functions do not require byte storage. Yeah, so the functions will have to be loaded onto memory when we call get balance. Like, for example, here when we say get balance, they have to be loaded onto memory. So the variables are already in memory, but if we call get balance, then we learn that functions are loaded onto the stack. So then they'll be loaded onto the stack while it executes. Once it finishes executing, it's immediately removed from the stack. That applies to free functions and class functions. Okay. So if I move this, make it public, first of all, this is always 100% of the time a no-no. You never want to do this. Once you do this, then you've broken encapsulation. You are no longer protecting your data, and any user of our class can come in and corrupt our data, regardless if it's your buddy programmer or even yourself. Like, you never want to do this, because if you have functions here that deposit and withdraw in balance, in bank account, and you have logic that has to pass before balance is modified, what assures you that anybody else is going to write that logic every single time they want to modify the balance? Notice here, anybody can corrupt your data, and we don't want that. So that's why it's very important that you make your data private, and anyone who wants to modify it, you give them functions with some data validation and some code that keeps the integrity of this guy. We always want to protect data integrity, and that is done with encapsulation. We protect our data. Okay, so I'll get to those questions in a little bit. So then notice I put it private. Now nobody can come in and mess with our data. Okay, so when the compiler reads our code for the class, the first thing it reads always is variables, whether they're private or not. It'll read the variables first and put them in its register, and then it reads the functions that belong to the class. So if the variables are read first, then it makes sense that the functions are aware that the variables exist. And that is the case. Notice right here, it knows that balance is from the bank account class. We didn't have to pass it in as a parameter, which is a gain already. Remember, with functions, anytime you want to work with functions, you have to pass in parameters all over the place, every single time. With classes, you will still have to pass parameters. We'll get to that later, but it's less frequently, okay? If you notice here, like, we don't pass in a parameter, so that means that, oh, balance is aware that this variable exists, okay? When we create more functions in a little bit, we'll see if functions know that each other exist. Questions here? Okay, so no questions. So we can conclude that if the compiler reads the variables first, then this variable is viewable in the scope of the class, like from this curly brace all the way to here. Anyone that belongs to the class can see it. Okay, so that makes sense. Okay, let's go back here. And then let's look at this abstraction. So we can deposit, and we can withdraw, and we can open. So we are modeling a bank account, real world object. I mean, we don't see it, but we know, like when you log into the computer, like the concept of a bank account exists. So we are modeling that concept. And we can give it actions. Right now, it only has one action, and that's get balance. Meaning some other object can interact with bank account by calling the get balance function. And remember, that's that's part of object-oriented programming. An object can have actions, can perform actions, and they can have actions performed on them. In this case, somebody's like, hey, give me a balance, and it's kind of like, okay, there's the balance. We can also give it another action, deposit. So let's give it a deposit action. So we go here and we say void deposit some amount, and then we have a semicolon. We're not going to write code here. Instead, we'll write code in the CPP file, because it'll take more than one statement. Here, we only have one statement, so we're okay with writing the code here, like it's fine. So we have to open bank account.cpp, include bank account header, and if we leave the code like this, the compiler will accept this, but it'll think that this is a free function. Functions that we've been writing before this week. To make it part of the bank account class, we have to say bank account : deposit. Now we can read it as deposit is a function of the bank account class. And notice if we type B, it knows that balance exists, which is good. What about this parameter? Where is this parameter coming from? Amount. We say integer amount. Users of our class will call deposit, and they'll have to send in an amount to us. So it comes from the outside. So that's why it makes sense here to have it as a parameter and not as a private data, because it's really not part of the class. It's just like, hey, I want to deposit $100 here. Here it is, deposit. So the bank account doesn't know like how much someone wants to deposit, so it just leaves that parameter there for them. Okay. We come here, and the question is, public, are they accessible to private and public functions? So we get the first answer here. Does deposit know that get balance exists? And if we hover over, then it's saying, oh, you want to use get balance from bank account. So yes, functions, class functions are aware that each of them exists. Can we go over here, and can we say, well, what about deposit? Does it exist? And it knows that it exists, right? So they know that they exist, which is good, because sometimes we will need to refer to them. Okay, so we go back over here, and our logic for accepting a deposit will be very simple. We'll just check if the amount is greater than 0. If it is greater than 0, then we will add amount to balance. Okay, so then we say if amount greater than 0, balance plus equals amount. And if it's not, we'll just ignore them for now. Later on, we'll come and add some code to return an error to whoever uses our class. But for now, it's kind of like, well, it's not greater than 0, don't do anything. Okay, so we go to main, and let's run this code first. Running terminal. So the balance is 0. Is that correct? We have balance. This right here means initialize balance to 0 when it's created. So we create it here. The next statement's like give me the balance, so it's 0. We can say let's deposit $50. Account. Now we can use the deposit function. If we do dot, notice now it's showing us the actions this class has. And if you recall from our string class, and we say string name, we create an instance of string. We do name dot. Notice all the functionality that programmers have written for the string class. Okay. What we've done so far is we've added 2 actions, which is okay, right? Like we're learning, so we have account dot deposit $50. Afterward, we can say, okay, let's display the balance again. And then we run it in the terminal. And notice our initial balance is 0. We deposit 50, we get the balance again, and the balance is now 50. Okay, so if we would see this in memory, this would change to 50. Okay. Questions here? Okay, so far no questions. Okay, so we go back to this diagram, and we've given the bank account, the deposit, and the get balance actions. And now can we give it a withdraw action? Yes, we can do that. We say void withdraw some amount. Again, why do we need this parameter? Whoever uses our class has to tell us how much they want to withdraw from our balance. And we will keep the rule simple. The amount has to be greater than 0, but it also has to be less than or equal to their balance. We created deposit here. And then we created the code for deposit here. So we come back over here. And we can say, okay, let's write the code for withdraw. And we come back over here. And I will sound like a broken record, but I want to make sure that you all understand this. This right here, so far, it's not part of the class. Why? C++ will consider this a free function. And number two, our code will not work because we are breaking our promise to the compiler that says, hey, withdraw with this semicolon, I promise you that I'm going to write the code later. And when the compiler sees this, it'll look for the code and it'll be like, sorry, I can't find where you wrote the code, even though we may think that this is it, but it's not. This is a free function. To make it part of the bank account class, we have to say bank account : Now we've fulfilled our promise to write code for the withdraw function. Okay, so withdraw belongs to the bank account class. It accepts an integer parameter amount. It will not return anything. Okay, so it's void. Questions here? If you don't, so this code will not compile if I do not include 50 here, because deposit requires a parameter. But the balance initially is 0. And then we add 50, so now the balance is 0 plus 50, so it's 50. Yeah, but if you don't include 50 inside the parentheses here, then our code breaks. Because we are not using a parameter. Notice right away it's like too few arguments in function call, because we're not providing it an integer. Okay, so we come back here and we will keep it simple. So we want amount to be greater than 0, so that shouldn't be difficult, right? Amount greater than 0. But then we also want amount to be less than or equal to balance, because I mean we're not going to let you withdraw more than what you have, right? Like if you have 50, then that's the max you should be able to withdraw. So we use the logical AND, and then we say amount less than or equal to balance. And if those two don't hold, then for now we will not do anything. But if they do hold, then we can say balance minus equal amount. Questions here? Again, this past lecture and this lecture are the building blocks for the rest of the semester. So if you have problems understanding, and you can go back and watch the YouTube video, just jump to the section where you were kind of like not fully understanding, or come to my office hour or ask questions here. Okay. I think I heard yesterday that there's only one tutor this semester. That's what I heard. I don't know if that's true or not. And that student usually is only available on Sundays. So I'm available Monday through Thursday, from 5 to 5:30 and after class. So if you have questions, please do not hesitate to ask, because if if right now, like, this is the line to success and you're here kind of confused and you ask me, then I can always like bring you back. But like if you wait 2 weeks and then you're over here and then I won't be able to like bring you back to catch you up. Okay, so it's always better just to ask me or your or another student, right? But ask. Okay, don't just be like, oh man, I don't understand, this guy doesn't make sense. Okay, so now let's go ahead and jump back to main. We've written our withdraw piece. So if we go back here, we now have given the bank account the withdraw action. And recall that's how we code for objects. We define an object, bank account, and then we identify its actions: deposit, withdraw, get balance. Okay, so that's what we are doing. Come to main, and then we will say, okay, so let's withdraw $10. And then we can say account. Why account? Why do we do account here? Well, because that's the name of our bank account variable in memory, okay? That's why. And then dot, notice now we have the withdraw function. And then we can say, okay, withdraw $10. And let's show the balance again. And let's go ahead and run this. So let's go ahead and make this larger. Balance 0, deposit 50, balance 50. Withdraw $10, balance is now 40. Questions here? Where we use const, then nobody can modify that variable, right? It'll be read only. So yeah, the question was, can we use const to protect the integrity of variables? So then if we use const, then in essence even the class cannot modify it. So then that'll always be read only. So that would not be a good solution. Okay, so questions so far? Okay, so what about testing? I mean, we've defined this so far in the class. Like, we created the class, we have public access, meaning get balance, deposit, and withdraw can be seen by users of our class. A user can be a function in C++ or another class. In this case, it's a function in C++, the main function. And if we do account dot, notice our list of public features is growing: deposit, get balance, withdraw. Also, no one asked me, this one is const, but why are not deposit and withdraw const? Well, because we know that in these functions we will be modifying the value of balance, and we have very simple logic to verify that the amount's okay, but that's okay, right? We're learning, and we do the same thing over here. If we would make deposit and withdraw const, then we would not be able to add to the balance. So in classes, when you know somebody's querying you or asking you a question about your variables, you use const when you return that data to them. That is what's happening here. Somebody's asking us, hey, give me the balance. So we just return the balance. And deposit and withdraw, we need to modify balance, so we don't make them const, okay? Okay, so now testing. let's test this guy. So we go to test, and how do we test? So we use the same workflow that we've used for homeworks. The only reason I went here is because you all probably have little exposure to how objects work. So I wanted to make sure that I would show you by developing an object and then using it in main to more or less show you, hey, this is how it works. And now we can go in and write some code to test our object. So we go test examples, module 6. Did I open it? Yeah, module 6 I did. Okay. So we go here and we have to include bank account. And then we say test case, test bank account balance is 0. And here new bank account balance is 0, right? So a new bank account. And what do? Well, we have to create an instance of our class. So bank account is the instance. And then we say, okay, so what do I do next? Well, let's look at the class. When I create a variable of bank account, balance will be initialized to 0. Okay, that's a good test. Let me use an assertion. So require that account.getBalance is not 50 but 0. Okay. And then we can go ahead and execute it. While it's compiling, are there any questions? Yeah, like a string, you can create different strings. So the question is, can I create account 1, 2, and 3 as we modify balances, and each account would maintain separate balances? Yeah, we can do that. You know, why haven't I done that? Well, because we are just learning the structure of a class, right? But if we come back and look at the stack, we have bank account A, it gets this piece here, and if we have another statement here, bank account B, then it would get its own memory, meaning there would be a balance for A and then a balance for B. And if we had a bank account C, it would get its own region of memory. So then we would have balance A, balance B, and balance C. And they would be for 3 different customers, and all of them would keep their own separate balance in memory. Okay, so green, as we know, is good. So up arrow, space, dashes, enter. So yes, notice our test case passes. Account.getBalance is 0, so 0 is 0, which is good. Now let's go back and what other tests can we do? Well, we can test the deposit function. So let's write a test case for that. So test bank account deposit with valid amount. Okay, bank account. Okay, did I misspell something? Doesn't look like it. Oh, sorry. Let me build it real quick. I think it's just confused. And it's building. Well, while it's building, I went to. So my daughter works in Round Rock at an acute physical therapy center, or acute center, right? Hospital. And I took. She was able to get me in to take my first dose for the COVID vaccine, which I'll probably need, because I'm thinking that ACC will soon be. I don't know how soon, right? But I'm pretty sure they'll send us back to the classroom, so I might as well get it. Right. Exit 0 is always good, so I don't know. I guess I lost my code helper, code IntelliSense, but it's okay. We can still be okay. So then we say, okay, so account dot deposit 50. And if I deposit 50, then I expect this to be 50. And just to make sure that I'm just trying to make a mistake on the side of caution, I'll just create the instance right away, and then I'll be like, hey, I want to test to make sure that the balance is 0. And then I'll be like, okay, if that passes, then I want to deposit 50, and if it is accepted, then I should get a balance of 50. Okay, so that's what I did there. So running terminal. Yeah, so I heard that the first dose is okay. It's the second one, which will be in April 21st. This might be harder on one. So I hope that it's not, because, well, I mean, I'll just load myself up on ibuprofen and get through the class, but I hope not. I don't have to do that. Yeah, that's what I hear, that the second dose is harder, so I'll just be ready with ibuprofen to get through the class, and then after that just crash. Okay, up arrow, space, enter. Okay, so notice we're good. 50-50, okay. Yeah, I got a text from Travis County Public Health saying that they gave me a link and you can go here and register, or if not, call this number to register or something like that. But I've already got my first dose. Okay, so questions here, and we're logically testing it, right? Create an instance, balance should be 0 when it's a new account, the way we've set up the code so far. And then I deposit 50, and then the balance should be 50. Also notice my, I think they were kidding, because, I mean, I cover the same material. Let me see here. Notice here, this is one test case. We're just testing the bank account balance when we create an instance. Here we are creating another test case with a valid amount, which means now we can maybe create another test case with an invalid amount. So we can say, so let me create a test case, test bank account deposit with invalid amount, and we know that an invalid amount, and the way so far in our case is just a ceiling, low, right? So if it's less than maybe not 0, less than 1, right, then we don't want to accept that. So we're like, okay, so let me create a bank account instance here. I'll go ahead and actually I need to do that, right? So why do I need to test this? Just to err on the side of caution, okay? And then why do I need to deposit? Well, because our balances start with 0. So I deposit 50. And then I go ahead and verify again that I've not broken anything, okay? And then I come back here and then I can say, okay, now I want to withdraw $10. And after I withdraw $10, I expect my balance to be 10, right? So deposit 50, get balance should be 50. Withdraw 10, we call get balance not 10 but 40, right? Any questions here? Let me see here. What am I doing? What invalid amount? I got ahead of myself. So maybe here we say -10. So if it's, well, actually no, let's do 50. And then here we purposely do account.deposit -10. And then I will ask you, what will I put there? It should be 50. Why? Why is it 50? Because of the way we've written our code, we were saying that if the amount is greater than 0, then we want to add it to the balance. Is 10 greater than 0? No. So then we won't execute this and we don't do anything. It just doesn't execute this statement. So the balance should stay the same. And let's test that. No, the Tuesday, Thursday class is not getting a lower quality of education. They actually did a little better than the Monday, Wednesday class in the exam. So, and that's what I told them, but you all did better. Yeah. So always green is good. So up arrow space -s enter. Let's go ahead and make this larger. Scroll. Test bank account deposit with invalid amount. So initial balance should be 0. We deposit 50. Should be 50. We try to withdraw $10. Nothing happens. The balance should still be 50. Yeah, I'll push this code to GitHub. Okay, so we have 3 test cases so far, and that's just for deposit. And now let's go ahead and test bank account withdraw with valid amount. Also, in the real world, it's a bank account always with 0. Not even in like poor economies, right? There's always something. So we're gonna have to fix this. So that'll be taken care of in the next lecture. Like we'll get introduced to another concept that will allow us to get the balance from externally, from use server class. Because the bank account's just there, and then we'll be like, hey, like when you create me, give me my initial balance. And we'll take care of that in the next class. Okay, so we jump back here. Test bank account withdraw with valid amount. Okay, so we know the drill now. Create a bank account object. And should I test? Yeah, why not, right? Like, let's keep on being safe. Okay. So it should be 0. We deposit 50, we should have 50, and this is a test case I was thinking about when I was typing earlier. So withdraw $10, and now what should my balance be here? $40, right? So it should be 40. So we have 0, we deposit 50, we have 50, withdraw 10, now we have 40. Okay, and let's go ahead and run it. I wonder why I lost my IntelliSense. What happened? You can't open it, otherwise our code wouldn't compile. It's working, so I'm not gonna worry about it right now. Okay, so we're still green, which is good. Up arrow, space, dash S, enter. And let me scroll up a little bit here. So test bank account withdraw with valid amount. So we create the instance, and then we say, is it equal to 0? Yes. And then we deposit 50. Is it 50? Yes. Withdraw 10. Is it 40? Yes, it's 40. Right. So notice here is where we were saying it should be 40. So far, we've implemented the correct code in the actions for deposit and withdraw. Now let's go ahead and look at our code here. So we're saying, so we have 2 more test cases, right? So we need one with amount greater than 0. Okay, so I mean less than 0. So let's test that. So test case, test bank account deposit with amount less than 0. We say, okay, so bank account require, oh, the IntelliSense isn't working, so let me just copy this. So we'll be cautious again, and then we will say, okay, so now let me try to withdraw negative $10. And when I do that, what should this be right here? It should be 50, because we've written code just to simply ignore if we get invalid data. So meaning don't do anything. So if it was 50, it should still be 50. Running terminal. Also, notice how the test cases can guide your development. Because if you can easily create test cases like we are, then that usually means that we are on the correct design as far as creating the actions for the class. If we have to jump hoops and loops and write weird code to make these test cases work, then we're in a bad design. So that's another way where test cases can help us. And we also are creating the bank account class, so we're like, oh, this is intuitive. But if we're like, hey, wait a minute, this doesn't make sense, then we can at this point fix it, right? And then other developers won't be like, ah, man, how do I use this class? So we're still green. Test bank account deposit with amount less than 0. So notice passed. So we're still good. Yeah, well, I mean, usually I always encourage students to stay away from cout. Why? Or what's the alternative to cout? It's always go back and inspect your code and select the value. Okay, if amount greater than 0. Okay, if amount 10 is 10 greater than 0. Yes. Okay, execute this. What was balance? It was 0. It was 50, right? Okay, so balance plus 10 is 60. So then my test case should be 60. So that's what I encourage. Like, stay away from cout and instead walk through the code, because then you're getting practice with code walkthroughs. But more importantly, you're checking your own work, right? So, and this usually works. Like, if you walk through the code, you'll find the error. I know I see students with cout, and I mean, I don't say anything, but usually it's just go walk through the code. You'll net better results like that. Yeah. Okay, so what other test case? So let's look at this guy. So now maybe we need to test this piece. amount has to be less than or equal to balance. So now we will try to withdraw more than what we have in the bank. Okay, so let's create that test case. Test bank account. This was not deposit, this was withdraw, right? Withdraw. Withdraw with amount greater than balance. Okay, bank account. Require, well, actually, let me do this. Usually it's pretty fast to type with the IntelliSense, but since it broke, and I'll just copy and paste. Okay, so are we good? Bank account, get balance is 0, deposit 50, balance should be 50. Now let's try to withdraw. $51. So what should our balance be? $50, right? It should be 50 because the code we wrote is like if the amount that to execute this code, amount has to be less than or equal to balance and greater than 0. So it is greater than 0, but it's more than the balance. So then we should still see 50 here. Running terminal. And it's thinking. So we want to see green, up arrow space dash S enter. Test bank account withdraw with amount greater than balance. So we start with 0, we add 50, we're at 50, we try to withdraw 51, the statement is ignored, and we still have 50, right? So that's when we get that nasty insufficient funds for this transaction, and you're like, what? Right, so questions? In review of what we've done, we've identified a real-world object that we want to model. It's the bank account that mostly everyone should be familiar with, right? You can get your balance, you can deposit into the bank account, and then you can withdraw from the bank account. We've shown you main code that shows you how we intend this to be used, this object. We can deposit and we can withdraw, and we can always ask it, what is the balance? We can also enhance our testing skills, right? So as we are developing code or actions, notice we are developing our test cases, which is good because by the time we finish writing this class, we're very confident that it works as intended because we are testing different scenarios, right? Maybe in this class we're not doing like the extensive testing that development shops would do, but that's okay. Like this workflow will transfer to the real world, and it can lend you a good opportunity, right, to work somewhere. So So any questions? Okay, so let's go into the bank account. And we always want our objects or classes that we define to model real-world scenarios or real-world models. A bank account, like I said a few minutes ago, is usually not zero balanced. It usually has some balance. If we go back and look at how we defined it in abstraction, we have these functions here, save to DB, database, or get from database. We're not going to do that, right? Obviously, we're not going to write code for, and we're not going to create a database. However, we can mimic that. So we need a way to force users of our class to give us the balance, whether that user uses another object to get the balance or whatever. We don't care. It's just when you create an instance of bank account, give me the balance. Okay, give me the balance and I'll take care of the rest. So that concept we will introduce in the next class. And we'll also introduce more concepts for classes. And we will go through all the 4 principles of object-oriented programming. So this class will, not this class, but this bank account class, we will develop for the next couple of weeks. Like we'll give it a lot of functionality. By the time we're done, we should have a pretty well-defined bank account class that you can use as a guide in your future development. And that's whether you program in C# or Java or Python, right? Like the concepts are transferable to other programming languages. Also, I was telling yesterday's class that, and I usually don't like to talk about like my kids, right? But my daughter, in this case, she graduated from Texas State in May. And then she wants to be a physical therapist, so she got accepted to UTMB. And before spring break, we went and we were looking at apartments for her. And she had applied like to Texas State and UTSA and San Angelo. And I think she got waitlisted at UTSA and Texas State, and UTMB accepted her. But yesterday, she called me and she said that Texas State offered her a spot. And now she doesn't know what to do because she likes the program at UTMB, but she likes the comfort of being home, right? So I'm going to tie it into this class, right? And to my personal experience. And she's like, I don't know what to do. But I told her, like, look at it on the positive side. You have options. Like the way I handle my early life, you know, like 2.0 student in high school, I thought it was a hangout place, you know, to go meet girls and hang out with your friends and find out where the next party is, right? And I had to go to a junior college. And I told her, actually, I did go to the junior college right after high school for 1 year. And I was an A student. And I'm like, but the party and seemed more attractive at that time. So I just quit going. Like I just stopped going for a while, like for 7 years. I'm like, and then I went back. But my choices were limited. I'm like, I had to go through the local junior college, Texas State Technical College in South Texas, Harlingen, Texas. I'm like, but both of us went through the same thinking, right? Like I decided, oh, I gotta do this. I'm like, you decided because thankfully you listened to me, right? Like all these years I thought she wasn't listening to me, she listened to me. But now, to you guys, no matter what you are going through right now, whether you're out of high school or you're trying to get back into college, or if you're a working parent or you work full time and you have to go to school, whatever it is, if I was able to do it by just lollygagging through high school, but once I decided I wanted to do it, I made up my mind I wanted to do it, and I did it. remember, this is not a sprint, right? If you're looking for a bachelor's degree, it's a marathon. You don't have to be the smartest. I'm not the smartest. You have to be very consistent. And you just have to, every time you don't want to do something, like your homework, you just do it and get it out of the way. And when you don't want to go to class, you just log in and get it out of the way. And when you don't understand something, then you figure out how to understand it, right? How can I digest this to make sense? And in my case, I mean, I grew up in the projects, right? My car would always break down, like my transportation to school. I think it was like a 25-mile drive, 30-mile drive to school. So sometimes it wouldn't start. And then I would call my friends, scrambling to call my friends. Hey, have you left? No. Hey, can you pick me up? Yeah. I'll give you some tacos or something, right? Sometimes I even would have to take the Greyhound bus, right, to the next town. But whatever it took, I just did it, right? So you all can do it too, right? Like, I know you're here because you want something better for yourself and for your kids, or if you have kids, right? And you are on the right track, but just remember, you have to stay consistent and you have to believe in yourself. If you believe in yourself, then you have no obstacles, because all the doubters, they're just going to be noise to you. So just remember that, right? That was my lead-in with my daughter, and I told her, you have options. I was in the situation because I put myself in that situation, but I told her, but I did it because I decided I wanted to do it. So you decide that you want to be successful, and you will be successful. Okay, so don't forget that, and I guarantee you, you will do it. When I was at the junior college, I still remember him, Dr. Peshesky. He was a college algebra professor. He would always encourage us, and he would always say, hey, I know you didn't want to come to class today, but you're here. And when you have that degree, believe me, your opportunities will expand. And he was true. It was true to his words. I was like, man, I can't believe this piece of paper all of a sudden allowed me to move from the projects in Austin, South Texas, to Austin, Texas, right? 20 some years ago. So y'all can do it, okay? Anyways, that was my encouragement for this week, right? I always feel that sometimes if nobody tells you can do it, how do you know you can do it? Especially if you're first generation college, like I was. I didn't even know if I was going to get a job when I finished college. But I didn't care. I was like, oh, this is my avenue and I'm taking it. So I bet on myself, and well, thankfully I did, right? So. Okay, so I will open the quiz right now, and I'll open it for 10 minutes. And you all can do it. I know you can. I mean, you all are on the right path. And I always feel that as professors, we need to at least share our experiences. A lot of the professors in the junior college were from Pakistan. And they shared their experiences. One guy, Mr. Malipur, he told us he was a dishwasher in New York City, and that he worked himself to death, but while going to school, but he didn't care because, he would go to school during the day, dishwasher at night, and he said, I just had to do it, and I believed in myself, and I did it, So if I, 2.0 guy from high school, was able to do it, you guys can do it too, easily. Okay, so I'll put 6:55 display, and I'll make it do at 6:55. That way y'all can take your time with this one. So it's 24th today. Submit. So it should be available. Quiz 6, it talks about function parameters, strings, and vectors. Okay, so you have 15 minutes. Take your time with this one.